Hello, sir. Hello. Hello, sir. So welcome, sir. Welcome to the session. So before starting our session, our honorable principal sir will address the session about the college, and today's session also sir will discuss. So sir, you can proceed, sir.
Okay, am I audible?
Yes, sir, you are audible, sir.
Yeah. Okay, good morning to all participants and Pantech solutions and other faculty members, research scholars, students, and other all those who attended to this 1 hour webinar on physical model based design of PV systems. So as of the today's 1 hour session on this particular topic definitely can enrich the physics fraternity of students, faculty, scholars, and working man with physics equipment. So definitely this program can make some new knowledge in the minds of the participants. Come to the institution. The GCSR college is an education arm of GMR Varalakshmi Foundation, a leading industrialist in the globe and particular in India, particularly in infrastructure sector. So the college was established in 1993 by the then Chief Minister K. Vijayabhaskar Reddy inaugurated the college, and as of now we are offering both intermediate and degree programs. In degree we have three combinations with physics: maths, physics, chemistry, maths, physics, electronics, and maths, physics, computer science. So the institution is a corporate arm. That means it's not a college with profit motto, because it is under the GMR Varalakshmi Foundation, where our beloved chairman GM Rao, so GMR popularly known as GMR, established this institution to cater the needs of this backward area. As you know, this Srikakulam district is a backward district. Razam is 40 kilometers from Srikakulam town and 50 kilometers from Vijayanagaram and 100 kilometers from Vishakhapatnam. So the college is catering the quality education from LKG to PG. So foundation is having not only junior and degree colleges, there are two English medium schools and one engineering college popularly known as GMRIT. So the college is a pioneer institution among 124 colleges under the affiliation of Dr. B.R. Ambedkar University, Srikakulam. Among all 128 colleges, the most preferred college is GCSR college. So you can imagine that for admission into BSc and BCom, we used to conduct a entrance examination. Based on the merit in the entrance examination, we use it to admit the students into our BS and BCom course. That indicates the credibility, the strength of this institution. So definitely this 1 day session, 1 hour session helps the physics students, physics faculty, and other research scholars and other physics fraternity. So I would like to thank Pantech organization for taking the initiative and extending their support for making today's webinar for 1 hour on physical model based design of APU system. I wish and I hope definitely this particular 1 hour session will be a very interesting and enriched session. Thank you. Now switch over to, please.
Thank you, sir. Thank you, sir.
Please, sir. Namaste. Yes.
Welcome to this. Welcome.
కరోనా కొంచెం నేర్పు.
Hello, sir.
లాస్ట్ డేట్ యాక్చువల్ గా మొన్న లాస్ట్ ఫిబ్రవరికి మేము సబ్మిట్ చేసాం, బట్ మనకి ఇలా కరోనా రావడం అంతా
Good morning, all. Welcome to all the participants. So I hope everyone doing fine in this pandemic situation. So welcome to all. So myself, about already principals are told about the college. So Department of Physics conducting this webinar on a physical model based design of a solar PV system. So if you need to design a 60-watt panel, how to design, how to connect the cells in a physical model. So when you people are making a real-time product, how to, first of all, we need to implement the physical model that is the first one. So then we need to implement in software, then we need to implement hardware. That are those steps we will discuss clearly. So welcome to all. So myself, Srinivas Luwala. So myself, Srinivas Luwala, I completed in my MTech in JNTU Anantapur, power systems area. So about Pantech Solutions, Pantech Solutions was established in 2004 in Chennai. So across South India, we have 7 branches. More than 100 employees are working in different Pantech Solution branches. We have separate branches in Vijayawada and Hyderabad and Cochin, Tiruchi, and Chennai also we have. And we have separate R&D sector also we have. Till now, we people are conducted more than 1,200 workshops in different areas. So we reached, from the last 16 years, we people are reached 850,000 students nearly. And our portfolio for research and development for industrial projects, faculty development programs, and hands-on training workshops, internships and in-plant trainings, short-term courses and value-added courses, academic project trainings, and customized design service and state-of-the-art in research and development areas. So in which area we people are offering the courses, and for technical people and non-technical people also nowadays all are common, right? For degree students also they are learning the technical, so they want to become a technocrat and they want to become a IT professional. So compulsory they need to learn in these all the domains. So for particularly not only for particularly engineering students, so we are offering Internet of Things, IoT, and artificial intelligence, embedded systems and robotics, VLSI, FPGA, TMS process, and image processing, OpenCV. So everyone know about the image processing. So everyone, we people are using the mobiles, right? WhatsApp and Facebook and Instagram we are using. So in that one, we are changing the color of our image, right? How we can analyze all the things means by using the OpenCV and image processing. And here network simulation and wireless communication. And for electrical engineering students, we are offering power electronics and electric e-vehicle also. For particularly now today the webinar is going on particularly physical model design for non-technical students mainly, but in those people also they can learn by using the Matlab. They can design any physical model whatever they need to implement. So here for computers and IT domain people, we are offering big data, data analytics, Internet of Things, Python, Android application development, data and image processing, cloud computing, mobile computing. So in all these domains, from the past few years, so from the not only from 2014 onwards, which technology is going in current trend in the industry. So in those areas, we are conducting the workshops, faculty development training programs, and courses also we people are providing. And we are the industrial projects also we are implementing. So here first, before starting to design a physical model of a solar PV system, first we can briefly we can analyze why we people need the renewable energy sources. In that renewable energy sources also mainly we are focusing on solar PV system, right? So why we are shifting, the world is shifting. Nowadays, globally also, if you are observing, everyone, they are trying to reduce the global warming, and they need to protect the environment, and they need to reduce the carbon dioxide emissions from the atmosphere. So then the all over the globe also, political leaders, they are also trying to implement in their countries to shift it to the renewable energy sources. In that renewable energy sources, solar renewable energy sources plays a major role. Solar PV system plays a major role. So why we people are shifting? So first of all, we need to know, right? So why we people are shifting means whatever the conventional energy sources, almost in Andhra Pradesh itself, if you are taking means, most of the energy where we are generating from the thermal power plants only, right? From that thermal power plants, we are getting the most of the power. So, but by getting most of the power from the thermal power plants, automatically atmospheric pollution happen, right? So like this, we people are using the conventional energy sources, whatever it may be, whatever the coal and natural gas, uranium, petroleum, diesel, all are comes under the conventional energy source, which are not reproducible, right? So we can't, once it will be exhausted, means once it will be expired from the earth, means we can't reproduce, right? So these are called non-renewable energy sources as per the IEEE standards, international standards. Also, research experts, they are telling now how we people are utilizing these non-renewable energy sources, petroleum, diesel, or coal. So like this we are utilizing means it will become up to 200 years. Hardly it will come 200 years. So then what will happen after 200 years? How we people can generate the power? How we people can generate the power means through the renewable energy sources only we can depend mostly, right? So these sources will come effectively, it will come 200 years. After the 200 years, how the world will be sustained? Without the power, we can't run the world, right? So we must, power becomes daily in daily life, it is most important, right? From morning to up to night also, it is playing a key role, right? So if you don't have the power means you can't operate any load, you can't turn on the switches, you can't turn on the fans and everything. Whatever the loads you are utilizing at your domestic application, you can't turn on those loads, right? So we need to effectively use these energy sources. At the same time, we need to focus on the renewable energy sources. So in that renewable energy sources, these solar or water or wind and geothermal and biomass energy, it will comes majorly. So these are the 5 areas we can generate. These are all comes free of cost only from the earth. So we can't buy the solar, sunlight we can't buy, right? And the water also we can't buy. The nature it will give, and we need to utilize that energy sources with an effective manner. How we need to utilize, how we can generate the power from the PV system, we can see here. So in that renewable energy sources, if you are observing, mostly free pollution mainly, and these are all unlimited supply, and it can be replaceable, and it will be low cost also, these renewable energy sources. Suppose when you are generating the power by using the solar PV plants, so then automatically it will be useful to your home and your particular area. So then automatically the electricity bills, mainly electricity bills, we can reduce easily. So then we people can economically, customers will benefit more, right? So here in that renewable energy sources also, if you are observing here, the basic operating principle of the solar energy system, if you are operating, whether you are putting the solar PV panels on top of your college. If you are putting top of your college solar PV panels, where you are taking the power, where you are taking the sunlight. So from the sun only you are taking the irradiation temperature on top of this PV panels. Then this solar PV will be converted into the electricity. So because these are all solar PV panels, photovoltaic energy will be converted into the electricity. So from here, which power we are generating from this solar PV panel? DC power only we can generate. So but when you are generating the DC power, so how you can generate? By connecting the solar cell. By connecting the solar cell, suppose you people need to implement the solar PV system, a 100 wattage of the panel you need to implement, or a 50 wattage of the panel you need to implement. Suppose you need to turn on your bulbs, 60 watt bulbs are there, right? And depending upon the wattage, we have different wattage of the bulb. So if you can develop a 60 watt of the solar PV panel, how much energy you can generate from that 60 watt of the panel also we will see in the design model. So here in the solar energy, mainly two types are there. One is centralized grid connected PV system and another one is decentralized grid connected PV system. So what is centralized PV system and what is decentralized PV system? Centralized PV system means, suppose in a big thermal power plant, we are generating the 800 megawatt power plant. If you are observing RTPP, Rayalaseema Thermal Power Plant in Kadapa. So near Produttur, we have one RTPP and Vijayawada also we have one thermal power plant, right? So we are generating 200 megawatt or 300 megawatt power from that power plant, right? So like that, when you are generating the huge amount of power like that, like 100 megawatt power plant in a big solar park. If you are considering near Visakhapatnam also, we have one big solar park, right? So, and in Kurnool district, 3 years back, we already 1000 megawatt solar PV plant also already proposed. So it will become nearly. So in India recently, Prime Minister of India already he started one solar big 750 megawatt solar PV park in Madhya Pradesh recently. So like that, in a big solar park, how we can create this solar park means, so we can take 1000 acres or 100 acres. In that 100 acres, we can put the solar PV panels in series and parallel. So by connecting the solar PV park, like we need to create a big solar park. From that solar park, we can generate the solar power. So, but we are generating in this solar park, which power we are generating? DC power only we are generating. But which power we are transmitting to the through the transmission lines? AC power only we are transmitting. But we need to convert this DC into AC, right? Otherwise, we need to transmit through the HVDC lines. So here, when you are connecting the solar PV panel in a big solar park, so suppose when you are connecting number of solar panels in series manner, what will happen at that time? There may be, suppose in Rajam, the temperature will be different. In Vijayanagaram, the temperature may be different. In Srikakulam district, the temperature may be different. If you are observing the temperature condition, sunlight temperature, in Rajam, the temperature different. Srikakulam, the temperature may be different. In Vijayanagaram, the temperature may be. Depending upon the location and weather conditions, the sun temperature will be different. Suppose when you people are implementing a big solar park in Rajam itself, 100 acres you are implementing. That means, so each panel will get the same sunlight. It will not get, right? If you are considering Rajam, Srikakulam, Vijayanagaram, we are getting the different temperatures. From that, when you are created a big solar park in Rajam, you will not get all the solar PV panels. All the solar panels will not get the same temperature, right? So at that time, what will happen? Insulation, that means insulation mismatching among the PV panels and the voltage mismatching problems will be occurred. Voltage mismatching problem. Suppose you are generating the power, but how much power you need at your home application? You people need, we are the customers, right? in domestic applications, we are utilizing, we need to turn on our fan or AC or any tube light also. We people need single phase supply, nearly 230 voltage supply we need, right? So, but due to the mismatching of the PV panels, voltage mismatching, and that means temperatures are different. So you will get each panel, you will get the different type of voltages you will get. So at that time, there may be voltage mismatching problem. And when you are connecting the number of panels, what will happen? Shadow problem will occur, right? Partial shadow will occur. So one panel you are connected, number of panels you are connected in a series manner, automatically the shadow problem will occur. So, and so like this, in this generation of the power, efficiency automatically reduced in the solar PV system. When you are created a big solar park, at that time, due to these problems, voltage mismatching problem, shadow problem, or due to the weather conditions, the efficiency at load side you are getting from the solar PV plant, it will be reduced. So then how to improve those problems, how to overcome those problems means decentralized. And the solution is decentralized PV system we need to prepare. That means you people know how much power you are utilizing. So the Rajam, in our top of our college also, how much energy we are consuming per month, we people will know, right? So whether we are utilizing 10 kilowatt of the power or 15 kilowatt of the power, we people will know means then according to the estimation of the power, how much we are utilizing per month. So by taking those estimations, we can install a big solar in 10 kilowatt of the solar PV system on top of our college means we no need to depend upon the grid side people. So where we are taking the power supply near to substation only, whether our college, whether our home, we are taking the power supply, right? So then you people are when you people are connecting like this, so when you people are taking the power supply from the substation, so in this case you no need to depend upon the grid side people. So here what will happen, you need to prefer the decentralized like this. The Andhra governments also they are preferring, right? We no need to focus on the centralized capital. We are shifting the decentralized capital, right? So like this. So in the centralized capital system, we are facing some problems, voltage problem, shadow problem, and the efficiency we are getting very less. So we know how much power we are consuming. So like that, we can, according to our estimation, we can install the solar PV plants on top of our home itself. We can utilize that power with an effective manner. So here you can see here. So what are the steps we have in the centralized PV system and the decentralized PV system? So decentralized PV system, suppose you are using the power. So how much power we are daily per month at a domestic application, how much power we are consuming? You can estimate 300 units we are consuming. 300 units if you are consuming means, suppose on top of your home you are connected the panels. How many panels you are connected? Number of panels, 6 panels you are connected. So when you people are connected the 6 panels, each panel how much wattage it will give? Each panel how much wattage it will give? So this panel wattage we need to maintain. So according to that, we are how much power we need? 300 units we need. Suppose if you are taking one panel 350 watts. If suppose one panel, take an assumption, one panel 350 wattage power it is producing. That means 3 panel means we can implement 1 kilowatt of the 1 kilowatt of the PV system. So 3 panels we can implement 1 kilowatt of the PV system. So like that, so 1 kilowatt of the PV system daily we can generate 4 units of the power. 1 kilowatt of the PV panel, it will give 4 units. 4 units only it will give. So monthly how much units you will get? 120 units you will get, but it will not sufficient, right? So then you need to shift it to the 3 kilowatt of the PV system. That means 12 panels you need to connect on top of your home. On top of your home, you need to connect 350 wattage panel only. 12 panels you need to connect. By connecting the 12 panels, how much power you are generating? More than 300 units. Nearly 360 units you will get a 360 units of the power you are generating. That means how much power you are utilizing per month? Hardly 300 units only you are utilizing. The excess power is there, right? 60 units of the power, your excess power. That power you can store in the battery, or you can give to the distribution. SPDSL, there are ESPDSL. So you can give the grid side people, means that company people will pay the bill to you. So you are all the loads at your home by using a 3 kilowatt of the panel, you are utilizing all the loads, and this power you are getting from the sunlight only. You are not and here automatically what will happen? It will reduce the electricity bill, right? So if you are considering, when we people are in lockdown, 3 months lockdown, after the 3 months lockdown, how the electricity bill, it will very huge, right? So they are changing the tariff plans and they are increasing the electricity bill. So if you are preferring the this solar PV system, decentralized PV system, when you are connected on top of your home, like this, means you can generate the power particular at your home or at your college also. So here, if you observe this one, it is a solar off-grid system. So here on top of your home, you are connected the solar PV panel, and here the loads, different loads, whether it is a fan or AC or a refrigerator or any washing machine, also different type of loads are there. From this load here, how to you can observe here in this solar off-grid system. Why we are taking this as a off-grid system means we are generating the power, the excess power we are storing in the battery only. We are storing the energy in the battery only. And here, when you are combinedly using two energy sources, you can call it as a hybrid system. So when you are preferring solar and wind, you can call it as a hybrid system. Hybrid system you can call. So two energy sources, one is solar and another one is wind. You have preference, it is called as a hybrid system. So if you are preferring the grid tied, as I said previously, so when you are generating 360 units of the power per monthly, so then by using the 360 units, so per day how much units you will get? 12 units you will get, right? So we can't utilize all the loads at a time, right? So one day we can utilize the 8 units of the power, one day we can utilize 6 units of the power. So when you have the excess power, you can give to the grid side people. That means distribution side people, means that people, they will pay the electricity bill to you according to the unit cost they will pay. And in India, rural cost is different, and the urban area, the cost. In the Visakhapatnam, the unit cost may be different. And in rural area like Rajam, in surrounding areas also, the unit cost may be different. It is around 3 rupees. So when you are into Visakhapatnam, the unit cost may be 9 rupees or 7 rupees they will purchase. So depending upon the location, the cost of the power also, it will be different. And here you can see, here we are observing different problems, right? Voltage and reactive power control, and the power quality, mainly power quality, and some fault right through cable. So when we are transmitting the power, automatically due to the heavy rainy season also, due to the lightning strike occur or any trees are fall down on the transmission network, means then automatically some fault will be occur, right? So those faults we need to clear automatically. We need to clear, then we need to distribute the power clearly, and so then we need to satisfy the customer mainly. We need to satisfy the customer mainly. So how we can overcome those problems? How to design this solar PV system in a Matlab. So we are telling some problems, whether it is a power quality problem or voltage mismatching problem or any fault right through capability problems also. When we are getting these many problems, when we are installing the solar PV system, we said, so the temperature from morning to evening, it is different, right? So we will get the different type of voltage. If you are giving the different voltages to your load side, that people will satisfy. Definitely they won't take other next time from your power, right? So we need to satisfy the customer. We need to give the quality of the power to the load side. Suppose every day we are getting the continuous power supply. If the power supply is not getting continuous, means we people will feel some annoying, right? So automatically we will get some hesitation to the grid side people, and we need to hardly also we can speak, right? So we need to give the quality of the power supply and continuous power supply also, and that is main thing. Continuous power supply we need to get. So how to give the continuous power supply to overcome all these problems means, so here MPPT is there. That what is MPPT means? Maximum power point tracking. So when we are installing the solar PV system on top of our home, so then we need to go with the MPPT algorithm. So this is nothing but the charge control. So whatever the weather conditions, whatever the atmospheric condition also, by implementing the maximum power point tracking algorithm, we can tackle at a particular point only we will get the maximum power, right? At a particular point, we will get the maximum power. From that point only, we need to track the PV power. So here, these MPPT algorithms, different type of algorithms are there in solar PV system, whether it is a fractional open circuit voltage or perturbed observe algorithm or incremental conductance algorithm or fuzzy logic control algorithm and artificial neural network algorithm and partial swarm optimization algorithm. Different type of algorithms are there. So we need to implement those algorithms in our required project or required research area. So then we need to track the maximum power to the load side. So here, this is the basic MPPT algorithm. You can see here. So automatically the temperature. So minute to minute, the temperature may be different, right? So we need to, according to this MPPT algorithm, this flow chart, we can tackle the, we can track the maximum power. So here, so where we can utilize how to design these things means, so the best platform in all the industry people, Matlab. So Matlab not only physics area also, Matlab have some good features. So in Matlab domain, we can design the physical model of a solar PV system. So this physical model, it is not a programming language. You need to remember, Matlab is not a programming language. It is a matrix laboratory. Here, if we people are strong in mathematical analysis, so we can design all our models in the Simulink design also. We can design all this one. So Cleve Moller was developed this one. And for especially engineering and research scientists, for their purpose only, Cleve Moller was introduced. Before this MATLAB, we have Fortran language and C++ and C languages are there. To understand the technical people and scientist people, it will be so much difficult. So they are facing so much problems. So here they are introduced the MATLAB. So by analyzing all the mathematical problems, we can solve our problem here. So here in the MATLAB domain, we have mainly 3 steps are there. One is model in the loop, and another one is software in the loop, and another one is processor in the loop, and another one is hardware in the loop. So we have mainly 3 steps are there. So here we need to design the physical model first. So then we need to test in the software. Then we need to go with the hardware in the loop. So different type of that. In this hardware, we can go with the processor in the loop. Processor is important. And this processor will give the switching signals. Switching signals in this processor we have, as we said, FPGA or DSP or TMS process we can utilize in this processor in the loop. And these are the models. So here, how to design a physical model in the Simulink and the Simscape. By using the Simulink and Simscape, we need to implement. So to analyze and dynamic system. So dynamic system we can analyze means. So this Simulink is the best tool. And here a model in the loop we can test, and how many test cases also we can write in the model in the loop. Here I will show the MATLAB. So here I am using 2016 A MATLAB version only. So not only for solar PV system, we can utilize this MATLAB in industrial area industry, aircraft or defense or automotive industry, communication, data analytics, financial engineering, image processing, and robotics also we can utilize this MATLAB. And here I will show the MATLAB domain here. You can observe here. You can see here, this is the MATLAB command window. This is MATLAB command window. So in this MATLAB command window, whatever the variables, if you are typing here, all the variables will be appeared in the workspace here. So here, you can observe here, I will show a simple model. So here, normally, generally, the name, variable name, how much we can give here means whatever the variable. Suppose if you are typing in this command window, if you people are typing A is equal any matrix, you can type here. A is equal 1, 2, 3, semicolon, 4 and 5, 6. So then you can enter here. So whatever the variables, if you are typing in the command window, it will be appeared in the workspace here. It will be appeared in the workspace here, right? So here 2 by 3rd matrix we entered, we given the command here, and it will be appeared in the workspace here. So here to find the rank of the matrix also we can find. So if you are giving the command rank, so it will be appeared. Suppose if you need to add something variable, for this variable A is equal A plus B is equal A plus 2 I am typing. So you can enter here means automatically all the mathematical problems we can solve by using this MATLAB command window. So here this is a command window, it will be appear, right? So to clear the command window, we can give the command here CLC to clear the command window, and here CLEAR, clear. Clear means workspace, it will be cleared here, right? So here to open or to stop the MATLAB means you people can give the command quit here, and enter means MATLAB will be closed. So you need to open the Simulink design. Simulink design means you can click here the Simulink, and otherwise you can type here Simulink and enter also. So directly Simulink library, it will be open. So most of the people, it may be new, but it is a very easy tool only, and most of the automobile industries, they are using all the, as I said previously, industrial applications. Most of the companies, they are preferring the Simulink MATLAB only. So all over the globe, more than 6,500 universities, they are working on this one. So all the researchers and engineers to analyze a model and to analyze the physical model and to design and to tell the specifications, this MATLAB is a good tool also. So it is not an open source, it is a licensed tool only. Here I will show a simple model, a solar, here I will show a simple model, solar module exercise. By using this Simulink example, you people will get some idea how to design the Simulink model. I will connect all the Simulinks where we need to get this solar PV blocks, all the things I will discuss. So here in this command window also, normally we can give the name, variable name 5 or 6 letters only, right? So but we can give just a minute. Here it is opening. We will see here. This is a MATLAB. All of you, I hope You can see here, this is a Matlab command window. In this Matlab command window, whatever the variables we are typing, you can visible, right? All of you. So in this Matlab command window, we can observe this thing. So here we can type in the Simulink library, Simulink, or you can click this one also, directly Simulink, it will open. Here I will show a simple model. So how to design the physical model, how to design. It is a basic simple model only. We will see here. So here, by designing the physical model, then we need to go with we can analyze how much wattage of the panel we can implement, whether we can implement 60 wattage of the panel or 100 wattage of the panel or 150 wattage of the panel. If you are going to market also, then you can find different rates, so 10 wattage of the panel, maybe it is around 650 rupees cost. And if you need to purchase 150 wattage of the panel, the cost of the solar PV panel, one panel cost itself, it is around 4,000. It is around 4,000. And if you need to install a 3 kilowatt of the PV system at your home means, and for your particular your home, you need to install 3 kilowatt PV system means the cost, it will maybe around 1,50,000 for 50,000. So then the governments also nowadays, the Andhra government and Telangana government and some governments, all the states in India also, they are trying to promote the solar PV systems and renewable energy sources. They are implementing a decentralized PV system. They are trying to implement because they need to, they are telling to give some awareness and by advantages they need to tell. And if you are observing in your surrounding area also, in agriculture purpose also, most of the people nowadays, governments providing the subsidies. So for that, they are purchasing the solar PV panels. By using the solar PV panel, they are trying to run the loads, agriculture purpose, and to run the motors in the agriculture field also, they are using these solar PV systems. And governments, they are giving some subsidies and some incentives also. And here, so in this Matlab Simulink, we will see here a basic model. We will see here. Yeah, you can see here, all of you visible. So you can see here. So this is a solar module exercise, which I connected 72 cells. 72 cells in the solar PV module we connected. How to connect the cells in series manner, we will see here. All of you visible, right? Solar module PV system. You can, I will show the each cell, I will show. Inside we created one subsystem. So what is subsystem means? To reduce the space of this Matlab window also, we created the subsystem. So you can see here, you can visible, right? All of you. So you can see here. All of you, if you are observing here, if you are observing here, we connected number of cells. How many we connected? 1, 2, 3, 4, 5, 6 solar cells we connected. So where we can get these solar cell means from the library. From the library, this is the library browser. In this library browser, we have different toolboxes are there. So in Matlab, more than 100 toolboxes are there. In that Matlab, we can implement this solar PV system by using the Simulink and Simscape. We can implement this solar module PV system also. So here, this is the library browser. You can observe here. So from here, these are the commonly used blocks, continuous, dashboard. So different type of blocks are there. From here, in this Simscape, from here, in the Simscape, you can get the solar PV system. And here, otherwise, if you know the name solar cell, in the search box here, we have one search box. You can type here solar cell. we can type here solar cell. You can see here, this is a solar cell. So how to take to our model means just click here, right click and add to block to your solar module model. So by connecting the module, you can see here. So we added the solar module PV cell, right? From the library, we are taking this solar cell. If you are observing this solar cell, how many terminals are there? 3 terminals are there. So this is one positive terminal, and this is one is a negative terminal, and this one is the irradiation block. So this triangular shape is irradiation block. That means here we need to, in the real time, we don't know how much irradiation temperature we are getting from the sun power, right? So here in the Simulink software tool, we need to give the irradiation temperature, whether it is 1000 irradiation temperature or 800 irradiation temperature or 500 irradiation temperature, different type of irradiation temperatures we can give here. So here, this is a physical block. This is a Simulink physical block only. In this physical block, if you are observing, this block is also MathWorks providing. If you double click in this solar PV cell, if you are double clicking in this solar PV cells, so in each cell, we have only 0.6 voltage. So here Matlab library browser, we have 0.6 solar cell we have at 1000 irradiation temperature. So then we know, right, how much wattage of the panel we need to implement. How much wattage of the panel we need to implement, we know, right? So if you are observing this block solar cell parameters, if you observe here, you can see here, what is the short circuit current they given? 7.34 they given. And the open circuit voltage they given here 0.6 open circuit voltage they given. And the irradiation temperature they given here 1000 irradiation temperature they given. And the quality factor here 1.5 they given, right? So here this block is providing by the MathWorks. So from the library browser we can take, right? So here, like this cell only we are taking, but here, how much each cell, you can observe here, in this cell. So how to connect the series means, you can observe here, I will show here. So here, just once if you take the one solar cell means, so then you can take here another solar cell. So here, by taking the solar cell, series connection means how we need to connect. So positive, negative I connected. And here again, so why here I am connecting number of solar cells in series means to improve the voltage levels. So when we have one panel, one cell, here it is giving 0.6 only. When you need to improve, when we need to connect the number of cells in series manner only, we can improve the voltage levels, right? So by connecting the cells, a number of cells in series manner, we can improve the voltage level. So here, all the cells here, what I am doing here, by connecting the series manner, So here positive, negative, I connected. So here the space it is occupying, right? More space it is occupying, right? So here like this, when it happened means, you can select all these blocks. You can select all these blocks like this. So then just right click here. On the Simulink software, you can just right click. Once you need to select all these 4 solar cells, you can right click here. Once if you right click here means you will get one pop-up here. You will get one pop-up. Here it is showing like this, right? So cut or copy or delete or create subsystem from the selection. That means Control G you can put here. So here we are creating the Control G. That means the space, it will be reduced very less, right? You can observe here, space is reducing. So here, the number of ports here, it is more, right? So how to connect here? So inside of the subsystem, this connection port 2, this is the connection port 2, right? So what is this one? In the solar PV model, 4 cells we connected, right? So for understanding purpose, I am telling. So this is, we need to give the name IRR. or you can give the name irradiance. Irradiance, you can give the name. So this input port, you can give the name irradiance. Second one. And here, this third one is there, right? You can remove this one and you just give to this connection to here. You just give the connection to here. You can observe here. You can connect here and you can remove this one. You can connect here. And this one is the positive terminal. This is the positive terminal. This is positive. Negative. This is negative. Negatives, right? So if you are come back here, it is reducing, right? So we have three ports only. One is irradiance and one is the positive terminal and another one is the negative terminal, right? So here like this, we connected here. How many cells we connected here? Number of cells we connected here. 6 solar cells we connected. This is for understanding purpose. You can observe here. You can observe here. How many solar cells are there? Each cell here. You can observe here. So here in this solar cell, we connected the series resistance we given. We need to transmit the power, right? We are converting the photovoltaic energy into the electricity we are converting. So here the series resistance 5.1 e power minus 3. And here each cell it will give 0.6 voltage. And what is the short circuit current? 4.7.5 only we are. That means current is 4 amps. And the voltage is one cell, it will give 0.6 voltage only. So like that, how many cells we connected? Total number of cells, 6 cells we connected. By connecting the cells, we created one subsystem here again. So this one I am removing. So here by connecting this series connection, I created a subsystem. So again, what I did here, these solar cells, this is the irradiation and this is the negative terminal and this one is positive terminal. So this is one solar PV module, right? So like this, I connected again 3 solar. So from here you can drag here. So again, this is a 6 solar cell and this one is the 6 solar cell. Total cells, how many? 18 cells it will come, right? So again here we are connected in series manner only. Positive to negative we connected. And here this is the positive and this irradiation blocks we connected to here. So if you are observing these cells, how many cells here we are connected in series? 18 cells are connected in series, but 6 solar cells is one module, one solar PV module. Like that, here again, what we did here, 18 solar cells and 18 solar cells, we connected 2 solar cells. Totally how many cells we will get? 36 cells we are connected, right? So then again, here you can see here 36 solar cells and 36 solar cells. We are taking different 2 solar cells we are taking. We are taking different, totally 72 cells, one solar PV module. We have how many cells are there? This is a one total solar PV module which is having 72 cells inside. If you are observing in our mobile battery, in the mobile battery also we have number of cells are there. Number of cells are there. So according to the cells, how many cells if you are connected, the battery capacity may be different. Here we are connected, one cell is 0.6, like that we are connected 72 cells and with a resistance of the 5.15 e power minus 3 with a less resistance. So here after we need to give the irradiation block, right? So then again here from the library only we are taking the Simulink to physical converter from the utilities. From the utilities, here we have one Simulink to physical converter, physical to Simulink converter. Why here we are connecting the Simulink to physical converter means here this constant block, if you are observing here, this is a constant block, right? In this constant block, how much I given irradiation temperature? 1000 irradiation temperature I given. But this is a Simulink block, right? This is a Simulink block, right? But real time directly the solar PV panel directly will take the physical signal from the sunlight. So here this Simulink signal I am converting to the physical model. You can observe here Simulink to physical converter, this one. So by connecting the Simulink signal, by converting the Simulink signal into the physical signal again here. Then again to identify this solar PV module, how much wattage it will give, what is the voltage we are getting from this solar PV module, and how much current we can get here. We need to take two voltage, one is voltage sensor and another one is current sensor we are taking. This is a voltage sensor and the current sensor. Voltage sensor positive I connected to here, and the current sensor negative part we connected to here. And here this electrical reference and the solver configuration we are taking whenever we are working with the Simulink and physical models. At that point we need to take the solver configuration. That means linear or non-linear differential equation. Suppose if we are observing this solar cell also, in that solar cell one diode and one the resistors and one current source will be there. Parallelly it will be connected. From that only we can generate the solar PV current and voltage also we can generate from the solar cell. Again here what we did here in this current sensor, we connected one physical to Simulink converter. So here this is the display in real time hardware, means we can observe in the CRO or DSO, we can observe the waveforms. To observe the here we connected one display. In the display we can observe the what is the voltage, what is the current, what is the power, and here we connected one display, and here we can see the waveforms also. We can see the waveforms also. Here I connect multiply with the voltage and current by using a product block from the library. So we will get the power here. So here I am running the model. You can observe here. So here you can run the model. Here we need to run the model, this one. So it is compiling. Here it is compiling. So once it is compiling, the simulation will be started. Here we are giving the running time one only. It will take less time only here. Here, if you are observing, here we didn't write any mathematical, here we didn't write any programming. It is a design, physical model or design only. If you know the mathematical, so how much wattage we need to implement and what is the rating of the PV panel we need to implement, when we need to means, when we know means, according to that we can design here. Already here some companies already they are giving the data sheet also they are giving. By directly you can take the PV panel also, directly you can take the solar PV panel. From that solar PV panel, you can select any data sheet, whether it is a TSM solar PV or Suntech Power or any companies, a different type of solar PV companies, they are providing some data sheet. According to that data sheets, you can implement your model also. So you can observe here, it is running here. Just a minute. Yeah, you can see here in this solar PV module. So what is the current we are getting? 4.75 is the current we are getting. From this, how much voltage we are getting? What is the open circuit voltage? 14.25. But how many cells we are connected? Number of cells, 72 cells, right? From that number of cells, 72 we are connected. But what is the each cell it will give 0.6 only, right? If you are observing from that 72 cells, we can consider this 14.25 is the maximum voltage which we can generate from this solar PV module. This solar PV module 14.25 we are getting, and the current how much? 4.75 we are getting, and the total power by multiplying this voltage and current we can get 67 wattage. So this solar PV module is a 67 wattage of the PV module. You can observe the graph also. In the so DC means it is not a bidirectional power flow. It is a constant unidirectional power flow only. Unidirectional power flow, and here we need to maintain the less distortions, voltage distortions. If you are observing, when we are getting the different temperature in the atmosphere, like that, when we are getting, if you people are getting the voltage mismatching problems, voltage distortion, DC voltage in the, you are not getting the constant DC voltage means, if suppose if you like that type of voltage levels or that power, if you are giving to the load side means the load may be damaged within the short within the less time. The product, the long life of the product, it will be reduced. You can observe here, this is the current and voltage and the power. So the voltage, DC voltage we are getting constant DC voltage only, right? Constant DC voltage only, constant DC current only. So this DC we need to convert into the AC means, then we need to implement some devices, converter topologies we need to implement. So from that inverter we can convert this DC into the AC supply. We can connect any load, whether it is a bulb or fan means we can utilize that power. And here these are the solar cells. If you are observing in the library, we have one solar PV panel also we have. So here you can observe here from the power system and specialized technology, and here the renewables. You can observe here, as I said previously, we have in the Matlab domain, we have directly solar PV module or photovoltaic module or solar module also, both are same only. So if you are observing this PV module, in this PV module, different type of companies, they are providing data sheet. A data sheet also we have. I will show that one. Then we can observe the voltage and current characteristics, and voltage and power characteristics also we can observe. You can observe this. This is the one solar. So like this you can implement. You need to implement your own model means. So this is a physical model. This is a physical model. Suppose you know the mathematical and you know what is the power, what is the wattage of the PV panel you need to implement means. So directly you can take this one PV array. So here you can give the directly irradiation temperature, and here what is the temperature, whether you are following 25 degree or 35 degree temperature also you can give here. So if you are double clicking in this PV array block, you can observe some data sheets, different type of data sheets we have. You can observe here. Here, if suppose this is the module data is there, everyone. If you people are observing here, module data. If you observe here, one Soltech, one SPH 215/speed there, different type of companies they are providing data sheet. Some data sheets we have. From this, you can select any data sheets according to your model. According to your model, you can take any solar PV module. So here, how many solar cells you need to connect in series? So here we are connected 4 solar cells in series. One panel, one is parallel strings we are connected. So from here, by connecting like this, the irradiation array or irradiation temperature is there, 45 degree and 25 degree. If you people are observing this wattage, 213 wattage, it will give, right? So if you are observing the plot characteristics here, the solar PV characteristics, if you are observing, you can see here. You can observe here. This is the voltage and power characteristics. So how much voltage we are getting? 150 voltage we are getting. 150 voltage, and here what is the power? 600 wattage of the power we are getting, right? So you can observe here 150, near to 150 voltage, and the current how much here? 8 amps, right? Nearly 8 amps we are getting. Here in this PV module, if you are selecting this data sheet, means from here by connecting the four solar PV panels in series and one parallel in string, and here how much? 150, more than 8 amps you are getting, right? So from this 800 wattage of the PV panel you can create here. So if you are observing here, each panel, if you are observing in real time also, compulsory they have what is the open circuit voltage and what is the maximum voltage we can generate. If suppose, if you are observing here, the open circuit voltage of the solar PV panel 36.3. But what is the maximum voltage you can get? Maximum power point. When we are implementing maximum power point, 29 voltage only we can get here. 29 voltage only we can get. So here, if you are observing the characteristics also, if you are observing the short circuit current or current at maximum power also, you can see here the characteristics you can see here. So these are the characteristics according to the modules. So if you need to connect more number of modules, if you are implementing 8 modules and 2 parallel strings if you are implementing, at that time you can plot the graph. So it may be different. You can observe here. So here the wattage may power, how much power it is increasing? It is nearly 3.3 kilowatt of the panel we can create from this solar cell data. We created 8 solar PV panels in series, 2 parallel strings, 300, nearly 300 voltage, and current how much? 15 amps. So 300, it is almost nearly we can get 4 kilowatt of the PV panel also we can create by using this data sheet. According to our requirement, we can implement. So all of you, thank you all the management and principal sir for accepting our invitation and giving this opportunity to the Pantech Solutions. And in this pandemic situation for organizing this session also, our sincere gratitude to the coordinators and the management of GMR College, and the principals are also a sincere gratitude to all of you. And thanks to all the participants for spending your valuable time. So subscribe our channel. Every day we are updating with the new technologies, and we are coming up with what is the advanced technology is going in the present industry. We are every day we are conducting 2 type of webinars also, and here you can subscribe and you can give your comment also. So thank you all. Have a nice day. Stay home. Stay safe. Thank you all.